Hello everyone, this is Abhishek Mahanti and welcome to lecture number 2 of the chapter Current Electricity. So students, in lecture number 1 we had discussed about what is the meaning of electric current, how to calculate electric current, what is the unit of electric current, and then we had discussed about the mechanism of flow of electric current through a conductor. And in that topic we had discussed about a new term which is known as the drift velocity of electrons. So students, in this lecture we will discuss about this new topic. The topic name is the relation between electric current I and the drift velocity Vd. Basically we will derive an equation which will relate I and Vd. We know that electric current through a conductor means the rate of flow of charge through any cross section of the conductor. And the drift velocity means the velocity with which, the average velocity with which the free electrons are drifted from the lower potential to higher potential region inside a conductor under the influence of the applied electric field or the applied potential difference. So to derive this relationship, I have taken a conductor. You can see that this is the conductor, and I have connected a battery of potential difference V across its two ends. So PQ is the conductor, and the area of cross section of the conductor is A, and the length of the conductor is L. And the number density of free electrons means the number of free electrons per unit volume of this material. This conductor is made from some material, maybe it may be copper, it may be aluminum. So for the material of the conductor, the number density of free electrons is small n. And due to this potential difference or the electric field set up inside the conductor, the drift velocity acquired by the electrons is Vd. So these are the data given, and we are going to derive the relationship between I and Vd. So to calculate current, we first need to calculate the amount of charge flowing through any cross section in unit time. Suppose I will choose the cross section at this point Q. Suppose I will choose this cross section. And now I am interested to calculate the amount of charge flowing through this cross section in unit time, means in 1 second, and that value will be the electric current. So when the key is closed at time t equal to 0, the free electrons situated at this cross section, they will start drifting towards the higher potential. Because you can see that this cross section P is connected to the positive terminal, and the cross section Q is connected to the negative terminal. It means P is at higher potential and Q is at lower potential. So we know that the free electrons, they move from low to high potential inside this conductor. So when you close the key or the circuit is closed at time t equal to 0, the free electrons situated at this cross section, they will drift towards the cross section P from lower to higher potential. So remember that at time t equal to 0, the free electrons which are located at this cross section, they are termed as the first batch of electron. I will call them as first batch of electron. So the first batch of electron, they will drift towards the cross section P from lower to the higher potential. And what is their velocity? Their velocity is Vd. Vd means the drift velocity. Now tell me, what will be the time taken by the first batch of electrons to reach at the cross section P? Their velocity is V, and they have to cover the distance L in order to reach at cross section P. So the time taken by the free electrons to cover a distance L is T equal to L by Vd. Distance by speed will give us the time. So at time t equal to 0, the first batch electrons, means the electrons present at this cross section, they will start drifting towards the cross section P, and they will take this much time. They will take this much time to reach at the cross section P. Is that clear? Now, the electrons which are present behind the first batch of electron, it means the electrons in this conducting wire, they will also enter inside the metal, inside this wire. Is that clear? So I will call them the second batch electron. So the first batch electron, they will reach at the cross section P after this amount of time. Now tell me, where will we get the second batch of electron after this amount of time? The second batch of electron will be somewhere here. Is that clear? Similarly, the following batch electron, means the third batch electron, they will also be somewhere here. So now just imagine, if the electrons are continuously flowing, then in this much time, in the time interval t equal to L by Vd, how many electrons will cross the cross section Q? Just imagine the scenario. This is the entry, this is the entry gate, and the electrons are gradually entering through this cross section and they are heading towards the cross section P. The first batch electron, they have reached at cross section P in this amount of time. The second batch electron will be somewhere here. The third batch electron will be slightly behind them. The fourth batch electron will be somewhere here. So all the electrons which have crossed this cross section in this amount of time, they will definitely lie inside this cylindrical volume. They will definitely lie inside this cylindrical volume. Is that clear? So if I can calculate the number of free electrons, inside this cylindrical volume, then I can calculate the total amount of electrons that have crossed this cross section Q. Is that clear? Because all those free electrons who have crossed the cross section Q, they are contained inside this cylindrical volume. Is that clear? So this cylinder has volume A into L, because A is the area of cross section, L is the length. So volume of the cylindrical region, volume of the conductor is how much? It is A into L. Is that clear? And here I have written that the number density of free electrons is small n. It means number density of free electrons means the number of free electrons per unit volume. If small n is the number density of free electrons, then the total number of free electrons contained inside this cylindrical region will be n into Al. So total number of electrons crossing the cross section Q in time t equal to L by Vd is capital N is equal to small n into Al. This is the total number of free electrons crossing the cross section Q in this amount of time. Is that clear? So what is the value of current? I is equal to total amount of charge that has crossed this cross section divided by the total time taken. And how to get the charge Q? Q is N into E. N means the number of free electrons and E means the charge of electron, and T is this much, L by Vd. So T is L by Vd. And what is capital N? Small n into A into L. So I'll write NaL and then I have to multiply E divided by L by Vd. So L will cancel and this Vd will go to numerator. So finally we'll get I equal to NaE Vd. I is equal to NaE Vd. So this is the relation between electric current and the drift velocity. Is that clear? So now look at this equation. I is equal to nAev. N means the number density of free electrons for a given conductor. Small n is fixed, and for the given conductor, area of cross section is also fixed. If I have taken a uniform rod or uniform wire, then A means the area of cross section will also be constant. So n is constant for a given conductor and A is also constant, and E, the charge of electron, is also constant. So out of these four terms, N, A and E all are constant except Vd, because we know that Vd is equal to EV by ml into tau. So if we change the potential difference across the conductor, we can change the drift velocity of electron. So Vd depends on the potential difference. Also it depends on the value of tau. Tau means the relaxation time. So if we increase temperature, then tau will decrease. If I decrease temperature, tau will increase. So Vd can be changed by changing the conditions. Okay, so N, A and E, all these quantities are constant for a given conductor. So I can say that I is equal to some constant into Vd, some constant into Vd. It means I is directly proportional to Vd. Electric current is directly proportional to the drift velocity. If Vd increases, I will increase. If Vd will decrease, I will decrease. Is that clear? Increase of Vd will increase the value of current, and decrease of Vd will decrease the value of current. So this is the relation between electric current and drift velocity. So that's all for this lecture. In the next class, we'll discuss about Ohm's law, which gives us the relationship between electric current and potential difference. And also from Ohm's law, we'll discuss about two new concepts, which is resistance and resistivity. And all of you have studied about resistance and resistivity in class 10. So that will be easier to understand for you. So again, that's all for this class. I hope that you have understood this derivation. If you have any doubt, you can ask me in the comment section. So we'll again meet in the next class. Till then, have a nice day and bye bye.